Hello everyone, welcome to my presentation on Chapter 11, Trees in Discrete Mathematics. I'm Nabil, and in this session, we'll explore one of the most important structures in this discrete math and computer science. So, what is exactly is a tree? A tree is an undirected connected graph that contains no simple cycles. If you have a collection of disjoint trees that call a forest, one key property of a tree is that there is exactly one simple path between any pair of vertices. Also, a tree with n vertices has always have exactly n minus 1 edges. Trees are used in many real-world applications, such as representing hierar- hierarchical data, like file system, and solving routing or spanning problems. Now, let's talk about rooted trees. A rooted tree designs one vertex as the root, and all the edges have a natural direction pointing away from the root. Here's some important terminology. A parent, a parent is a node that has or more children. A leaf is a node with no children. An internal node is a node with at least one child. We also define the level of a node as its distance from the root. There are different types of root trees, such as binary tree, where its node has at most two children, M-array trees, where its node has at most m children. Uh, Trees are not just theoretical; they're incredible practical too. Here are some key applications. One, binary search tree or BST. Used for efficient searching, insertion, and deletion on average. Operation take O log n time. And two, decision trees, widely used in AI and machine learning for decision making and classification. So the next is Huffman trees, used in data compression algorithm to create optimal prefix like those used in save file and PNG image. So the next tree traversal means visiting all the nodes in the tree in a specific order. There are three main types. One, pre-order. Visit the root, then left subtree, then right. The two, in order. Visit the left subtree, then root, then right. So the post order, visit the left subtree, then right, and then the root. For simple tree, if we have a tree like this, then the traversals are pre-order A. Visit the root and left to the right. In order, visit the left subtree and the root and the right, like usually we post order. Visit the left, the right, and the root. Ah, Spanning trees. A spanning tree of a connect graph is a subgraph that uh, includes all vertices, is connected, has no cycle, contains clearly, and minus one edges per vertices. This concept is useful is designing network, such as telecommunication or electric gate, where you want the full connectivity using the fewest possible connection. So what a minimum spanning tree or MST? A minimum spanning tree or MST is a special kind of spanning tree. It minimizes the total weight of the edges in a weighted graph. MSTs are useful when we want to reduce costs, for example, in laying down cables or pipelines. Keep in mind, an MST may not be unique if there are edges with the same weight, but it always contains exactly and one edges. MST algorithm. There are two popular algorithms to find the minimum spanning tree. One, Prim's algorithm. Start with any vertex, repeatedly at the smallest edge that connects to a new vertex, work best for dense graph. The, the classical algorithm sort all edges by weight at the smallest edge that doesn't form a cycle, works well for sparse graph. These algorithms are used in real-world problems, such as design the cheapest network between the cities. So we got the conclusion here. To conclude, the trees are an essential structure in the secret math and computer science that are used for organizing and processing data, making decisions, compressing data, design an optimal network, and understanding the tree traversal techniques and minimum spanning tree algorithm is crucial for solving real-world optimization problems. So thank you so much for uh, watching. If you found this presentation helpful, feel free to rate or leave a comment. This is Instagram. This is my Gmail. Once again, I'm Muhammad Ramgani. See you in the next session.